while we are setting up, I'm going to get you all out of the realm of AI and Gen AI for now. I had asked a question earlier. What is a screensaver and why is it called a screensaver? I had one person come and tell me, I know why it is there, right? Any takers for actually coming and giving me the answer? Because this is in accordance to Puneet's slide of curiosity about Albert Einstein. Be curious about it. Any takers of why a screensaver is actually called a screensaver? Does it actually save the screen? You want to give it a shot?
Okay. All right, that's my guess, but I think it has something to do with, in the earlier days, there used to be time sharing machines where there used to be one CPU and there used to be multiple, and only one person could use it. So I think it has something to do with that. I don't know.
Time sharing machines. Wow, I have no idea what that is. But yeah, any other takers of why a screensaver is a screensaver? Come on. This is your time to actually come on stage and...
Hello.
Yeah, go ahead.
Hello. Yeah, so I think it's to save the screen, like there was LCD burns that happens in the older displays, and that is because of a very bright white light constantly turned on, like the LCD working for a very, very long time. So it goes under a burn, and the screensaver actually changes the lights to stop that burning. The displays don't burn. So it's just little screensaver.
Kind of, but it's kind of wrong. Sorry.
My answer is also kind of the same, but it was not for the LCD. It's for CRT. There were phosphor burns, because of which screensavers were used to save the screen.
Spot on. So you got it partially, not LCD, not liquid crystal display. CRT, cathode ray tube, lasers, hitting the screen with phosphorus behind to create luminescence, which is why your screens have a hertz. The frequency, it has to hit that before your eye can detect a change. So the matrix screens, which are green colored thingies, laser used to keep hitting the screen and get phosphorescence. But if you get up and go for a coffee, for 15 minutes, it keeps hitting the same spot, which means every time the laser hits that particular pixel, it is going to generate little amount of heat. And for 15 minutes, if it generates that much heat, that screen would literally burn. And that time, the screens were expensive. So to save that screen, there would be a TSR program. Oldies in the house, what is TSR? Terminate and stay resident program, a virus. Would actually activate after a particular amount of duration and change the pixel ratio. That's why you would always have a screensaver which moves around the screen. And that's why it was called a screensaver. So well done, guys. Meet me later. I'll get you a free ticket to the conference next year. Okay. Was the claps for the free tickets or for me? Our next speaker is Vishwajeet. And he is going to dive into the IoT realm and how Ruby, AI, IoT are all in the mix. So over to you, Vishwa.
Hello. Am I audible? Yeah. Yeah, so the topic name is connecting the dots because we are going to dive in deep into many such diverse technologies or aspect of the things that can connect together to make a better living, or I would say. So hi, myself Vishwajeetsingh. So I work at SimplySmart as a principal software engineer. So SimplySmart is a product-based company which deals with it's an end-to-end water management solution for all the most of the residential and commercial places that you can possibly imagine. So we mostly work with from diversely from hardware to even at the end from mobile apps to all those things to control those hardwares and make the things even smarter. So at the bottom you can see in the logo itself we are saying we are making simple things smart. So it's actually the motto and the goal of our product. Yeah, so let's start connecting the dots. Yeah, so a small animation just to. So first thing is that since we are understanding IoT devices and all, so the most crux to understand is that the time series data, because the hardwares and all the most of the people who has worked on IoT based systems, they know that the things generate lots of data and it's time bounded data that it generates periodic time data, and from that we can do all those things like we can get the data, we can get the analysis over it and any sort of stuff. So time series data is one of the basic crux that how things communicate and things gives us kind of a knowledge what actually happens with those things. So what are the challenges in IoT-based systems? Like, for example, there are so many things, like since we are dealing with so diversified, discontinued, I would say, like connected over internet sort of things. So there are so many challenges, but out of that, I listed few which are prominently faced by us as well. The first one is proactive maintenance. So you can see see here it's not good to have like whenever you are installing certain sort of hardware, and after certain times it doesn't work and your customer is saying it doesn't work, and then your hardware person goes like this and solves the problem. It's not an actual way of solving anything. Yeah. Then the second one is abnormal usage, because you can see the example as well. They're just playing with the water, but it's not an actual expected usage out of that particular thing, which can make us smarter by attributing it to digital meters and all those things. So how to solve this question? So at the start, while dealing with these sort of things, so we first thought of going ahead with rule-based systems and solving these issues, but with time we found out that you can't just standardize certain things, because everybody is using in a different fashion. Because you can't just generalize conditions in Pune and Chennai. So considering the maintenance as well, you can't just consider a particular hardware to work for 3 months. Who is working for 3 months in Pune can work for 3 months at the same time in Chennai as well, because the conditions are different and all those things comes into the play. So what's the solution over it? So the solution is obviously machine learning. That's the ultimate solution for every problem that we face. Like if it doesn't get solved by rule-based system, that should be solved by machine learning, right? Yes. Yeah. But machine learning with Ruby? Would it be possible? Because whatever I have searched, whenever I'm trying to implement and all those things, every time I'm getting an answer is that use Python or R or any, even Julia, SQL. Even I got in some cases that you can use plain SQL. But I guess I didn't find any single blog saying that use Ruby for some sort of analysis and doing any machine learning over it. So let's try. So I wanted to give a shout out to this guy who has done a lot of work in Ruby. So his name is Andrew Ken. He has done around contributed and even created many packages, around 170 plus packages he contributed, and which has around 160 million plus downloads. So it's not that he's just developing and just creating a repos out of it. So, and the main thing about that, all the certain sort of packages that he developed for to helping us to actually implement machine learning using Ruby are predominantly written in Ruby only, not like some packages which are giving a wrapper over a Python library and giving you back. Yeah? Yeah, so this is the first library I want to explore you all through, that we need something to perform certain sort of mathematical calculation over it, because we know that in machine learning, most of the things at the ground level is mathematics at the end. And there is so to have a certain sort of alternative to NumPy, so NumPy is used in Python. Similarly, this library can perform most of the actions or any sort of calculations that we need to perform for AI and machine learning sort of applications. Secondly, the data frames. We all know that the most popular packages in machine learning with Python as well, NumPy, Pandas, and Matplotlib. Because first handles mathematical calculations, second handles how data gets loaded, and we can process it out. So Rover is a package which can help you deal with all sort of data into data frames to perform any sort of analysis over it. Then comes one of my favorite. So while researching out of it and all those things, I found out this package which is kind of a similar, similar in fashion to scikit-learn. It has all the basic sort of algorithms related to machine learning are already been implemented, and you can directly use it. I am here using a classifier using support vector. Yeah, you can see this is a simple example showing that we have loaded the application, then we are getting the data, we are training it out, and even we have dumped it within a file, so that the first part is a training part, second part is actually we are just getting that dump file out of it, and then we are getting tested it over a test data. So similarly, what you can do, you can have that train data set and then dumped it out in a simple way. In machine learning terminology, it's called pickling. Similarly, you can get the analysis and the predictions out of it in like 10 lines of code. Yeah. So I'm not just adding it out to have that sort of just mimicking or comedic stuff, but it's actually a package named Daru, which is in Ruby. So it stands for data analysis in Ruby. So that's the package that you can use for performing the data analysis. Yeah. So these are more packages as well. Like there are certain like fast text, NYA plot. So fast text is mostly deal with like whenever you are dealing with textual data to perform any textual predictions or any details over it that. Whereas these two packages, NYA plot and Vega, are more towards like plotting the data over like charts and all those things, so that you need to have that visual analysis over it as well. Yeah, so now the main topic that we have already discussed, like there are two problems that we have faced earlier with IoT systems. First is the proactive maintenance, and second one is abnormal usage. So you can solve those problems using anomaly detections. So let's deep dive into that. The first one is, I'm just giving a simple example with this one, like these are point outliers. So what you can infer about it, that if your system is, any system which is continuously giving this sort of anomalies, like single point of anomalies, it can be possible that there are certain sort of events that has caused it. Like for example, there can be short circuit sort of stuffs which has happened, these sort of anomalies. So you can infer, if you are able to detect these sort of anomalies very discreetly, so that means that there's sort of third party, there's no issue with the meter or any sort of sensors. The issue is with the supporting systems to it. Secondly, what if these anomalies are too frequent, like these ones? So you can see here, like there are subsequent anomalies continuously happening. So in that cases, you can proactively say there is some issue with the meters or any sensor sort of things. So the hardware personnel or somebody can directly proactively go and check the issues with the things, instead of like some customer is raising complaint and then going. Yeah. So we are just, this is a simple code, like just 8 to 9 lines of code, which is detecting an outliers in the systems. So we are using Prophet RB here. So many of you already who has been working with like machine learning and sort of stuff with time series data, if you are using. So Google has provided a Prophet library, which has been used in Python for a longer time. So similar to this library is kind of a similar alternative in Ruby, which can be used to detect outliers of the systems. And then we can, if we can detect the what is the frequency of those outliers, and then based on that we can deduce like what sort of alerts or what sort of proactive actions we can get. This is a sample data for which I have, this is a smaller data for which I have already, we have plotted the data, and you can see that there are certain sort of anomalies in the data for smaller period only, but there are some. So we need to have that check because there are, I guess, 3 instances and 4 instances of the anomalies. Now, the second part, the abnormal consumption, abnormal usage part or any sort of stuffs. So while there are so many algorithms, anomaly detection algorithms I have gone through, like there are CART, there are some deep learning sort of algorithms as well. But what I intrigued is that while dealing with the cases that we are dealing here more into, like the data is continuously increasing because we are dealing most of the time with the water meters and sort of stuff. So our data is continuously increasing. So for that purposes, detection by forecasting was one of the best use cases, one of the best algorithm I would say, which can be worked on with. So what it does actually, it first trains over the large amount of chunks data, and then that model predicts the future values. That will forecast the values, like what should be the next value of next like 10, 20 values that can appear in this, that particular meter can send. And if that particular sensor sends like anything which is farly deviated from the predicted values, then we can consider those as abnormal usage. So the difference is that the first one we are talking about, that there are issues with the meter. The second issue, that abnormal usage issues we are dealing with, is with like there might be some usage, like for example, if there is electricity sort of metering, that we already all have the electricity sort of metering in our houses. So if by any chance there are certain sort of heavy utilizing electricity devices, on, and the particular home, all the people are at the vacation or something. So at that time, it's continuously getting used for 24 hours. So that will show an abnormal usage alerts and all those things using this detection by forecasting. Then, so I have done a small sort of a demo with it as well. So we are actually removing the anomalies. So that's why I mentioned that that particular trend data should not have any anomalies. Otherwise, your data will start, the forecasting data also will start generating anomalies from it, because it is trained from the anomalic data. So we are taking the data. So I'm just giving a small readings and all those things, which are ranging from like 100 to like 9,500 or all. And we are using the rover that we already discussed that for data framing and all. So we are loading the data, and then comes the part forecasting the data. So what we are doing here is that we are easily fitting. So those who have already worked with scikit-learn, the similar terminology is finding here. For training purposes, the prophet uses .fit functions. So it's fitting to the data that we are providing it, and it's generating a model out of it. And then it's firstly generating the future data frames, because then it need to understand what sort of periodicness it has. Because since it's a time series related data, then it needs to have that sort of time framings, that what's the next time frame that for which we need to generate the data. Because every sensors, every sort of sensors can have a different time frame. Some can have every 2 minutes, every 10 minutes, every 1 hour, every 1 day. Yeah, so for that, and then we're actually predicting for those future data frames, we are predicting what sort of values we are getting, and then we're plotting it over a chart, or we can, actually I have plotted it over a chart, but what you can do, you can get those data, and then subsequently over the time period, because it's not good to have like your machine learning model is running whole day for your system, that continuously it is generating, predicting, because you need to perform all the other tasks as well, because your customers will not wait for that much time. So what you can do, you can just predict it for like a next 1 day, and you can predict those values for whole 1 day, like what values are actually coming and what are forecasted values. If there is a huge deviation between those two, you can send alerts and all those things, and at the night you can again retrain it, because your data analogy or the patterns in the data usage is continuously changing. So this is the graph that we have already generated. So you can see here that the black dots are actually the values that we have already given to the system for training purposes, whereas the blue line that you are saying is the prediction value. So if you can see here that there is small deviation from the values as well at the end, but it's not that a bigger deviation, so we can't consider like abnormal usage. But if going ahead, if there is a huge deviation from this forecasted values, then we can say it's a anomaly or any sort of abnormal usage to share that with customers and all those things, that there might be some sort of appliances is continuously working. Yeah. Then I know I was running like yeah. So these are all the things that we have already discussed, and that we have discussed time series data. What are the challenges in the IoT system for which means we can use machine learning with Ruby to solve those things and using anomaly detections. My main notion was not here to have like saying like for all the applications go and use Ruby. But at the start while doing it, I was little bit like in some sort of discomfort, like for just smaller sort of analysis also should I go with Python? Because my whole system is using Ruby, and just for that smaller analysis I'm going ahead with Python and writing in another microservice and dealing all the things with that. So that's why I started researching, and I would urge people to do explore those things with what Andrew Ken has done, because he has done excellent work with like machine learning as well as Postgres monitoring, because most of the time we are using relational databases, and he has given so many packages and all those things to help us analyze indexing and other sort of stuff, so that we can enhance and improve our experiences with it. Yeah. So thank you, because I've already been like a panel discussion on AI, and I'm again talking about same thing. Still, there was no any like nobody has left the, I would say, the auditorium. Thank you for that. Yeah. So finally, so if you have any, if you think like your commercial apartments or any sort of commercial apartments, residential apartments and commercial, any sort of things can benefit using this solution, like water-based solutions and all those things, do connect with me. Or if you want to discuss ahead with like how we can contribute to this machine learning sort of to increase the usage of machine learning with Ruby, do connect with me. Yeah, so that's my X handle, sorry. Thank you.
Questions?
Yeah.
Yes, sir.
Yeah, can you hear me?
Yeah.
Yeah, so just wondering, is the only reason you're using Ruby for machine learning is because your existing systems were in Ruby?
Yeah.
Or is there any other technical aspect to this decision?
So why did I choose the topic? I already said that just because so my notion was like for everything we should not go ahead with like we are picking all the things at all sort of different things and collecting it to form something which is optimum, I would say. So even we can, so my notion was like we can use Ruby also for some sort of smaller application, because we are using Ruby on Rails for end devices applications, and we are for just smaller applications. Again, I'm going with some sort of another technology, then support it up, and then do it. Then we will have another developer and sort of stuff. So all those things come to mind, and I said, let's try out and work it out using Ruby on Rails. So that's what engineers do, right? To work it out with the problems, yeah.
Yeah, so you use Rumail class
Yeah.
as an alternative to scikit-learn.
Yeah.
So you did not perform any data splitting. So like, was it because the test data was already like too small?
Yeah, yeah. So what I did, like, I didn't do any test data splits and all, because I already splitted it up. You can see like the file namings and all those were different, and I didn't show that in the this particular demo because my main objective was to have how anomaly detection can help in IoT systems. Otherwise, I would have, yeah.
So like, does Rumail class have any methods for that?
Yeah, so Rumel does have class methods to perform those as well, and as well as predicting more sort of accurate. So I was just using a normal function to create accuracy metric. So
And,
there are advanced as well, yeah.
and what about errors? Like, does it provide errors also like scikit-learn, like mean square error?
So there are other, like I would say the confusion matrix one. Like there are other matrices as well that you can use. I have just used the smaller one because I wanted to have just an intro to things like what are the packages that you can refer to start with things. So there are actually, but I haven't mentioned it in the talk itself. Yeah.
There's a question here. I'll get you a mic.
Hi. So just a question about that environment where you were running the Ruby code for machine learning. It looked really similar to Jupyter Notebook. What's the name of that tool?
Yeah, so it is a Jupyter Notebook. There is a gem called iRuby. Using that, you can use the same Jupyter Notebook that you are using for Python for Ruby kernel.
Okay,
So
so
that
you can do a gem install iRuby and then we can use Jupyter Notebook.
You can use gem install iRuby, and then you need to just while creating every new file, it will ask you like which sort of kernel you want to use, because by default it's a Python. You can mention it. Yeah.
Okay, thank you.
There is one more, I guess.
One sec. Let's get a question here first.
Hello. Yeah, hi, this is Ajit.
Yeah.
I work as a software engineer in G2.
Yeah.
My question is, does these libraries also harness the power of GPUs like TensorFlow or PyTorch?
Yeah, so not actually the basic ones, but there are variants of these ones as well. So which uses similar capabilities like Torch GPU and sort of a PyTorch GPU that can enhance that can use all the GPU capabilities as well.
Thank you.
Yeah.
We'll take one last question here.
Hello.
Yeah.
Yeah, hi. So my name is Bonish Agarwal. So I've been working with Python from the past 2 years, right?
Yeah.
So my only question to you was, I wasn't aware of the Prophet library you mentioned that can detect outliers in a time forecasting data.
Yeah.
But then it's not that easy. My first question to you would be that, do you know any math beyond the Prophet library, that how does it detect the anomalies or the outliers?
So, so you are saying like up to the mathematics. So in Prophet as well, since I haven't directly given any sort of functions to it, it does allow us giving us a specific functions to refer and generate the graph that I'm saying, forecasting graph. So there are different sort of stuff like, so the one I was using also. So there are different sort of, since you are saying mathematical function, you can go with regression sort of algorithms, which has some sort of mathematical weight, or you can go with like isolation forest is also one of the options to go ahead with, yeah.
Okay, so just to add one more thing, when you talked about anomalies detecting outliers,
Yeah.
let's suppose we come up with an example of getting the very basic use case of time forecasting data is stock market, right?
Yeah.
So let's suppose if I have to predict Nifty 50 for the next year, and I have the data from 1990 to 2024, right?
Yeah.
So there is a consistency of the Nifty points, right?
Yeah.
From 1,000 to, let's suppose 17,000 we have right now, or let's suppose from 12,000 to 70,000.
Yeah.
But in between, COVID came, like 2020 and 2021, and we saw a great downsurge in Nifty points. It came down to 2,000.
Yeah.
Will the profit library consider that data point from 2020 to 2021 an outlier, or will it consider it for prediction system?
So the thing is, if you're just giving that particular data, like these sort of values has been coming from like 1990 to like 2020, I guess. So up to that point, then it won't be having that I would say knowledge that currently COVID is hitting. So in that
No,
case,
from 2024. But from 1990 to 2024.
Yeah.
So it has the data of 2020 to 2021.
Yeah.
So will the library you mentioned consider that as an outlier?
Yeah, it will consider if there are sudden drops from it. If it is a progressive drops, if you are considering, because that depends on the particular stock. If it is a progressive drop, then it won't consider it as an outlier, because it's continuously saying that because forecasting is not always about like all the values are getting with the 1,000 range, and suddenly means there are with gradually decreasing from 9,500 to then that's not anomaly. Suddenly if there is a drop to 200, that's anomaly. In that case, it will detect.
So let's suppose if there was a drop in 2020.
Guys,
Yeah.
stock
Yeah,
market.
sorry.
If it's going to be a positive outlier where I'm going to make a lot of money, let me know. But I would recommend that you all take the discussion. It's an interesting discussion. Let's stick to the facts
Yeah.
Okay.
for now. Okay?
Yeah.
But
Thank you.
do take the discussion
Yeah.
ahead.
I will take.
Any other questions about the stock market? All right. So, Vishwajeet, I just had a simple question. You mentioned good talk,
Yeah.
but you mentioned water management.
Yeah.
Water management. So so is your company into water management, like the overhead water tanks, water meters, smart water metering?
So, so the main thing behind is that whenever there is a so considering water as well. So, for example, there is a society or any sort of commercial complex which has a single inlet of coming complete water, but there are multiple outlets in it, and then to manage that thing, like we are just going ahead and charging, or anyway, we are considering that everybody is using in equal fashion, but it's not actually. So to manage that thing, there is a end meter.
Asan shabd mein kaho.
Just sorry.
Smart water metering.
Yeah, smart water
Okay,
metering.
fine, cool. And any particular reason you changed your hairstyle?
No.
All right, cool. Loud round of applause for him, please.
Yeah. Thank you.